Dun, dun. Okay, let's see. It's the medium. Separate squares, part 1. You're given a 2D integer array of squares where squares of I is x, y, and L represents the coordinates of the bottom left point of the side length of a square parallel to the x-axis. What does L mean? And side length, okay. Find the minimum y coordinate value of the horizontal line, such that the total area of the square is above the line equals the total. Oh, interesting. Answers within 10 to -5 of the actual answers will be accepted. Squares may overlap. Overlapping areas should be counted multiple times. So find the minimum y coordinate. Since here could be anywhere between these two squares in order for the areas to be the same. Okay, sure. Okay. Interesting. Very unique. Alright, so how would I go about doing this? I wonder if I can do binary search here. Yeah, I think I should be able to do binary search if I just guess the number. And if the number's too low, then guess a higher number. Binary search would find it even if it's like a decimal value. Key thing about doing binary search is always writing the search function or the check function. So check whether or not so here the input would be the y value. The input would be the y value. And the output would be what? Output would be, so it's 10 to the -5th is the thing. So with binary search, are all these squares going to be integer coordinates? They are integer coordinates. Maybe there's going to be 2 binary search functions. One is to find the integer that works, because the minimum integer would what I'm trying to say here. So if I do a normal binary search where the input is the y coordinate, and the y coordinate could in theory be something that's non-integer as the actual answer, it just opens up space too, it would be too big of a space, because the minimum coordinate could actually be very, very precise. It could be actually, could it? Well, within 10 to the -5th of the actual answer. So even if the actual answer is y equals 1, I could even answer 0.0 or 1.001 or something like that. 1.0001. Actually, maybe I don't need to actually make some modification for when the answer is actually the minimum. It'd be an interesting version of this problem if it was like, if the actual answer is a kind of rational number that you have to give the exact rational number, but if it's not a rational number, then you can give some approximation of it. That would be a much interesting, or much more difficult problem, maybe, likely. But here, I think I can just do a dummy version of it. So anyways, binary search, I need to just create a search function that does the calculation of whether or not a particular y coordinate works. Whether or not a particular y coordinate works. What do I mean by works? I think I mean maybe the area above the y coordinate is greater than or equal to the area below it, or something like that. Can't be exactly equal to, that's just not gonna be, it's just not gonna work. It's too difficult. Okay, so let's say is possible is my general name for binary search function. It'll return true if area above y coordinate input is greater than or equal to area below. So let's say the y coordinate. I guess this can't be an integer, right? It has to be a double or a float. Let's say this is the y line. This is the float. This return is going to be a boolean. Let's for now return false here. And the general setup for it is, actually, how am I going to do this? 0, 0, 2. The length. So the area is just going to be the difference between the y coordinate. Assuming that the y line is between the top and the bottom. So x doesn't matter. X coordinate is just irrelevant, just based on the y coordinates. Okay, so key thing here is it needs to be a single pass. So it needs to go through the whole array in one pass in order to determine true false return value. Let's say above is going to be the area above, and below is going to be the area below. So for every x, y, and length, I really don't like using L, so it's like a 1 I, capital I. Don't also x, y, length in squares. So I guess here, if the line is strictly below, let's say if y line is less than or equal to the y coordinate of this thing. And this is the bottom left y coordinate, so this means that it's equal below. So square is above line. So above should increase by the area of this box. Else, let's say if y line is, if the y plus the length is less than or equal to y line, which means that the y coordinate plus the height is less than y line, which is the square, is below the line, is strictly below the line, then below plus equals length times length. Else here the y line is between it. Square y line kind of splits squares. Splits the square. So this is above should be equal to maybe I should just do something like area equals length times length. And then the top part is going to be, maybe the bottom part's easier to calculate actually. Bottom part should be the y line minus the y. Is the height of that bottom part times the length. That should be the area. And so that bottom part should be increasing the below total below area. And the top should be increasing by the total area of this minus the bottom part. Okay, so that iterates over, and then it should do something like return if the above is greater than or equal to the below. Alright, so here binary search should be something like, what is the bounds of this thing? 10 to the 9th. 0 is the lowest, so it has to be, so it's above the x-axis. So the low should be 0, the high should be 10 to the 9th. And then while what is this going to be? While I think the difference is greater than 10 to the negative 5, I'm going to say. While the difference is greater than 10 to the negative 5. High minus low is greater than or equal to 10 to the negative 5. Actually, 10 to the negative 5. Probably want just a decimal that. So the delta is 10 to the negative 5. Actually, does this work? I think we have tried powers with negative like that. I think it probably works. While the difference is greater than the delta that I'm looking for, the mid value of binary search is going to be low plus high divided by 2. Float division here, or double division here. Float. And then let's say return value of the binary search function is going to be that. And if the return value is positive, or if the return value is true, then that means there's more area above than there's area below, which means I need to move the line upwards. So I need to search in the top half. So I think low should be equal to mid. Normally it'd be like mid plus 1, I want to say. The plus 1 might be too much. Mid plus delta? Or it's just mid? I think it's mid plus delta. Mid should be the lowest false area, lowest false value. Mid should be the lowest false value. Low is initially false if you plug it into the function. Yeah, my gut says this should be mid plus delta, just like if in a normal one where you don't have where low and high are integer values, then it'd be mid plus 1. I think here is mid plus delta. Else high is equal to mid. Yeah. And then the end of it should be some mid value that works, or some low value that works. I think this should just be return low. Top. It should be above, not top. Oh shucks. So on 2 versus 1. What's the second one? Okay, well that one is pretty good. This one is very not good. Huh. This XY is the bottom left point. Okay. Returning 2 versus returning 1. Ah, interesting. Yeah. So right now it's giving me the largest that can, rather than the smallest that can. So there's something wrong with my logic here. I think there's just, I need to switch the overall logic. Maybe return true if the bottom is below the top. Return true if the area below is less than, is greater than, area top. Just reverse this logic. So return below less greater than equal to above, and then does that work? No, then this thing needs to reverse mid. So if returns true, then I need to set high equals mid here, and then set low. High equals mid, low equals mid plus delta still, I think. Alright. I don't feel great about how quickly I switched that logic without really thinking about it. It was just more intuitive. I mean, let's just run it and see if we need to fix more stuff before trying to reprocess it. Oh, interesting. That's pretty slow, huh? 244 versus 2200. Oh boy. Oh boy. Yeah, now that I think about it, I should definitely be maybe sorting it. Yeah, I should be sorting it. This is just too random. Alright, well, yeah. This is definitely, this is definitely something where the difference between my solution and the optimal solution is not like, it's a order of magnitude, or not even order of magnitude, that's the wrong expression. It's the difference between like efficient. It's a difference in like time complexity, um, class. Like this is like O of n log n, and this is O of n. Is that how you split time complexity class? Class. Yeah, so what's okay, maybe I just use AI mode here. What's the term to define to describe problems that are O1 versus O of n versus O of n log n time complexities? Would time complexity class be a descriptor for that? Asymptotic order group. Asymptotic complexities. Okay, so yeah, here versus here is a difference in both factors. Growth rates, order of growth, asymptotic complexity. So mine is order of growth of O of n log n. Should be O of n, I think. Well, I mean, sorting would be O of n log n. Yeah, I guess maybe it's just extremely efficient. Okay, whatever. I need to sort. So I think it should be squares sort key equals lambda, let's say tuple, where I'm taking the tuple of x, y, and length, and I want to sort by the y first and the length second. Not that syntax right. Squares sort Mike is not revalid return type. Line 75. What's going on here? Where's the area? Or where's the error? Must be a real. Oh, I see. Yeah, none can't work as a. Okay, 002, 011. Yeah, okay, that's what I want. So I think squares for that. 5 times 10 to the 4th. Huh. Well, is this really that slow? I think maybe the overall thing is fine. I just need to be more precise about when I stop. If I sort it, yeah, I think this might be overall fine. This shouldn't be that bad. What's slow about it is it will go through every single square before returning. But if I have it in sorted fashion, then maybe I don't need to go through every square. Because if I have it in sorted fashion, then the squares will do what? As I iterate over it, over the squares, assuming the squares are increasing in y coordinate, then I'm going over the lower squares first. Okay. I think I need to have a meta calculation of, or have a pre-calculation of the overall area rather than calculate on the fly like this. So let's say total area is equal to 0 for every x. Where I sort it, I can do for every x, y, and length in squares. Total area plus equals length times length. I wonder if I can do this with a list comprehension. Probably not. Anyways, so then as I pass over in the function here, I can just keep track of the below the line. The below value is going to be always increasing. The below value will strictly be increasing until it stops. Below. So I could do something like while iterate over it. So if the y line is above the y, and this is the y line is less than the y, then this is going to be strictly above. Okay, so this should just be break. This should just be breaking it. Don't care about above anymore. Low, that's fine. And I don't care about above, so I don't care about taking the area. And so below just increases by this amount. And then that stops and return if the below is bigger than 0.5 times the total area. this is all fine. I think maybe I can just do break if that, then I wonder if I can do this without the if statement. Y line minus y. Y plus y line. Y plus the length is less than 1. Okay. Guess I just might as well do SF here. Okay. Yeah, I think that might be fine. Do 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 do. It's not sorted previously, right? Given find the minimum y, minimum total area equals the total area of the squares below. Squares may overlap. Overlapping areas should be counted multiple times. Interesting. Well, there's a slight increase in memory and slight decrease in run speed. Like maybe less than 10%. Do, do, do. I mean, I think I sort it. I think sorting it's fine. And it is stopping at the earliest square that will make a difference. Is there some sort of calculation? Interesting. Interesting. So let's sort it. Yeah, maybe I'm just doing this wrong actually. Do I need to binary search it to be honest? Because if I go through interesting. Do 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 do. If you go through a particular if I go through the squares, if I iterate over the squares themselves, like this is probably just going to be a different way of handling it. If I iterate over the squares themselves, iterate over the y coordinates of the squares. iterate over the y squares. Man, this is actually really, that's really unoptimal, even if this is slightly above average. But I think there has to be some sort of way to actually parse through the rectangles themselves rather than using binary search. This is actually a difference between O of n versus O of n. We're still sorting it. So it should be O of n log n, but after you do that one sort, there should be maybe a one-pass solution to it. Whereas this is multiple passes after sorting. 10 passes after sorting versus 1 pass after sorting. So if you do sort it, how do you identify the Y line? Overlapping squares is the big issue. If all the squares were not overlapping, then you can do something like you can just increase the Y by 1, I guess, each time. And then if you increase the 1 and it switches, if you increase it by 1, and somehow goes from area below is less than half total area, and area above goes from less than half total area to more than half total area. When you increase the line, then you need to go backwards and increase the line by a smaller amount, like by half of 1, like by 0.15. No, you can't increase by 1, actually. Increasing it by 1 is just not going to be fast enough. I think you might increase by the height of the square. By increasing the height of the square, you could possibly be one of the key things. So you can go from one height to the next height. I guess that might be your delta. From one height to the next height, and then from here it'd be to here is the next. No. If it's here to here. So if you have these 0 and 2 as the 0 and 2 as the bottoms, what are the possible ideal placements of your line? 0 and 2. So maybe you start by the lowest y coordinate. So could it be lower than 1 at the start? Is 1 the actual minimum of any possible solution? No, it's not. Because if all the squares were at 0 on the y-axis, as the y coordinate, which is all the squares are on the x-axis, then the answer might actually be like 0.5. I guess 0.5 is actually the absolute lowest answer achievable in any possible input set of squares. So somehow you need to start with either 0.5 or something below 0.5 as a possible y. So what would you do here? You start with the y coordinate of low, or maybe y coordinate of low plus 0.5. It can't really be below that. But then in other places, it might need to be. So like if you had go up by every 0.5. La 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 la. Alright, this is too late. We're just gonna say this is definitely an unoptimized solution. This is either off by kind of an order of magnitude. So kind of missing a factor of n from kind of missing it, yeah, off by order of magnitude. So basically, instead of a one-pass loop, after sorting, it does kind of 10 passes, or it does log n passes, or it meets the optimal solution, or the most optimal, the most efficient solution is of a different order of growth / asymptotic complexity. At least I learned a little bit of terminology today. Or maybe I learned it at some point and I'm relearning it now. But anyways, the above solution is basically a binary search solution. To find the minimum y coordinate / the y line that divides the areas. So one, calculate total area and half areas of all squares to create the check function. Check is possible function, which needs to be kind of O of n. and returns true, false for a given y coordinate, whether the area, I think in this setup is below that line is greater than or equal to the area above. Uses the sorted squares array to make the what's the term, to short circuit the calculation, or to exit, or to break the loop early, and then use kind of low, high, mid loop of binary search to do binary search for the appropriate mid value or appropriate y coordinate, and then return the low or mid value. So this is kind of your basic binary search. Here the below is going to be the maximum. The below is going to be the maximum y coordinate that returns true, and anything that is above that is going to be false. Right? If I no, is that right? The low is the minimum. Sorry, the low is the minimum y value, that the minimum y coordinate where the area of the squares below that y coordinate is greater than or equal to the area above it. So technically I could have the y value be higher here and it would still be true. Like if I checked for the total area of the squares below y equals 2 or y equals 3, areas there would be at least half the total area. So I'm slowly kind of decreasing that low value to be kind of the lowest possible low value where it's still true. Yeah. So basically, it kind of goes downwards until it's not true, and you can either return high or low here technically, because they're within delta of the actual thing. Alright, time complexity is going to be O of n log n, unfortunately, to sort and then to do the binary search. Log n for the binary search and for the passes. Place complexity of 1 since no extra space is needed. Alright, quite disappointing.